You wait. So compute the values of half x plus 4. Okay. Okay, so for 2, it would be 5.
Yes. That is 5.
For 1, it will be 4.
What is half of 1?
0.
You're thinking half of 1 is 0. What is 1 times a half?
0.5.
Yeah. And so 0.5 plus a 4.
Oh, 4.5.
Uh-huh.
Okay, for minus 1, it would be half of it. Half of minus 1. 0.5. Wait, how do you get half of a minus number?
You just it is minus times plus.
And how long you took it for?
Okay, just minus.
So what is minus times plus?
Minus
Uh-huh. And a half times 1?
half. 0.5.
Yeah, so this time it's minus 0.5.
Okay, so minus 4.5.
That would be minus 4. This is plus 4. So 0 minus 0.5 plus 4.
Okay. 3.5.
Very good. 3.5. That does part A. How you do part B?
Sure. Okay, yeah. So you have to for the one that says 2 on x and 5 on y.
So 2 on x, 5 on y. Make a mark.
And then 1 for 1.4.
Yeah. 1 and 4.5.
And then 0 and 4. That one's just good. And then minus 1 and 3.5.
So 3.5 is halfway between 3 and 4.
Then minus 2 and 3.
Minus 2 and 3. And what if you got one of the x's was, let's say, here or something? You would be able to tell that it's not
yeah,
correct.
because it's a straight line.
Yes, you're right. And then last thing you do?
You draw the line. You connect the dots.
Yeah, we join them up, and they wanted the graph, so we join it for here. And I put a little arrow to show it goes forever and ever. And do I have it? Yes, they have the thing. Right, so you fill in the table of all the values, and then you plot the points, join them up. Any questions there?
Okay.
Okay. Right, how would you do the one on the left?
On the grid. Y equals x. On the grid, draw the graph of y equals x, 2x plus 3. All the values from x. X from x equals minus 3 to x equals 1.
So, any idea how you do that one on the left?
I don't know how.
You put minus x as -3 and see what you get.
Minus x minus you get plus.
You get 2 times -3 plus 3.
Okay.
So it's like the table of values, except we're just putting in the very last one and the very first one, so the two ends.
Okay. So,
So 2 times -3 plus 3.
2 times minus 3 plus 3. That would be -6. It would be -3.
-6 plus 3 makes -3. So when x is -3, y is also -3. And how about the other one?
3 minus x. 3 minus x to x equals 1.
So this time x equals 1.
Okay, so x equals 1. So then it will be 3 1.
Instead of 2 times x plus 3, it's 2 times 1 plus 3.
Okay. So it would be. So that would be 2 plus 3, which is 5.
2 plus 3 is 5. And so what coordinate is that?
It's 5, 5.
That is, no, when x was what?
1. Oh, yes. 1. 5.
And so, how can you use that to draw the graph?
You put, for the first one, you have to put the dots on 3 and 3. And where the 3 and 3, -3 and -3 connect.
So -3 -3.
And then that one will go where the 5 and the 1 connect.
So 1 on the x, 5 on the y.
Yeah.
And what do you do with those two?
Then you connect them.
And you connect those two. And they said they wanted it from there to there. And so we just do it from there to there. So for that one, yeah, you just do the those two end points. Okay, let's try this one.
Okay. On the grid, the graph of y equals 2x minus 3 for values from x. Values from x from -2 to 2. Sure. So 2x minus 3. So graph of y 2x minus 3. X is okay. So it would be 2 times -2. Which is -4. And then add 3.
Not add 3.
I'll take away 3, sorry. And that is -7.
Uh-huh.
And then the coordinate would be minus 2 minus 7.
Mm-hmm.
And then for the other one, it will be 2 times 2, which then you do 4 minus 3, which would be 1. And then the coordinates would be 2 and then 1.
Mm-hmm. And so how do you draw the graph?
For the y, you do minus t minus 7.
And so where does the minus 2, where's the minus 7? Which is which?
This on the y is minus 7 and on the x is minus 2.
Yeah, minus 2, minus 7. And the other one?
And on the x is minus 2, and the y is minus 1.
They're not minus, they're plus.
Oh, it's
2, 1. And the last thing?
and you have to connect the dots.
Yeah, we join those up, and there we go. Great. Any questions about that?
No.
Okay, and there's lots and lots of questions like that, and they're all very similar. Lots of those. That one was a half, we did that. So a half x. There's negative ones. Oh, let's try this one.
Okay. Please call the graph of y equals 0. Okay, so it will be 2 times minus 4 minus 2 minus wait. Yeah, 2 times minus 1.
Yeah.
Okay. So 2x times minus 1 is 2x times minus.
So 2 times minus 1?
2 times minus 1 would be minus 3. No, sorry, minus 2. Just minus 2.
Yeah, and so you've got 8 minus minus 2.
Yes, okay. Then 8 minus 2 would be minus 10.
Do you know what happens to minus minus?
Tangential.
It becomes a plus.
Okay, that'll be 10.
So that becomes 10.
And the coordinate would be minus 1 and then 10.
Mm-hmm.
Then for the next one, it would be 8 minus 2 times 4, which would be 8 minus 8, which is 0.
Mm-hmm.
And then it'll be 0 over 0 then 4.
All the way around. 4, 0.
Oh.
And so minus 1, 10. And how do you do 4, 0?
4, 0. You do the 4 on the x and then the 0 on the x as well.
So yeah, it's just 4, 0, like that. And last thing,
Then you connect the dots.
join them up. That is it. Well done. Let's see. So what do you give yourself for drawing graphs?
Half.
You did quite well. So this is about gradient. So this one, the line was going down, so it has a negative gradient. Previous ones, the line was going up, so it had a positive gradient. And the more it's going up, the bigger its gradient. The more it's going down, the less its gradient. And so the way you can find the gradient is change in y over change in x. So for this one, how much did the y change? Yeah, what was the change in the y coordinate? How far up did it go?
In the y went up 4.
Yep. And how many? What was the change in x? How many right did it go?
It would 2.
And so what is 4 divided by 2?
2.
Yep. And we use the letter m for gradient, and it's basically how many up over how many right, or the fancy way to do it, y2 minus y1 over x2 minus x1. So that just means first y take away second y, second y take away first y, second x take away first x, and that is that change in y over change in x. So in this one it was 7 take away 3 over 3 take away 1.
Okay.
Okay, so find the gradient between these coordinates.
Gradient between these up. Okay, so for x it has changed by 3, and then for y it's changed by 15. And then it will be 19 divided by 15.
So 19 minus 4 is 15. How about the x's?
Oh, then you do 2 minus 5, which is 3. So then 15 divided by 3 is 5.
That's it. And so the gradient is 5. So that would be a line that looks something like that. For every 1 right, it goes 5 up. Okay. Number 2.
Okay. Number. Oh, find. So for y, it will be 2 minus 4, which is 2. And then for x, it will be minus 3 minus 5. Will just turn to plus. So then it will be 7. 8, sorry.
Yes, so 5 minus 3, and that's 8. 2 over 8?
That's 4.
8 over 2 is 4. 2 over 8?
Minus 4.
No. Simplify.
2 over 2 over 8.
Divide both by 2.
0.25.
Yeah, or a quarter. You can half the top, half the bottom. And question 3.
Okay. For y, it would be 8. 8 minus 2, which is 4.
Nope. Eight divided by 2 is 4.
Oh, 6.
And you're always doing them the wrong way around. It's 2 minus 8. So it's always the second take away the first. So 8 minus 2 is 6. What is 2 minus 8?
Oh, 6.
8 minus 2 is 6. What is 2 minus 8?
Oh. Minus 6.
Minus 6. Yeah.
And then... Okay. Then for the x, it would be 1 minus 1. 1 minus minus 1. So that will be 2.
Mm-hmm.
And then and then 6 divided by 2 is 3.
6 divided by 2 is 3.
Or minus 3.
So minus 6 divided by 2, minus 3. Well done. So the first one was a positive gradient. The second one is a fractional gradient, so that would be something like that. And then the third one is a negative gradient, and so that would be going down like that. Any questions about those?
Yeah.
Okay, so we did one of each. 5, a quarter, and minus 3. Exam question. Let's try it.
Exam question. Just the point. Huh? What does PIS mean?
Where do you see that? Oh, it's just a space. It'll be P is.
Oh, okay. Okay. So the gradient. So 1 minus. Wait. So this is for Q. I think. So 1 minus 4 is 5.
Okay.
And then 4 minus 5 is 9.
So first one, you did second takeaway first. That's correct. So you have
Oh, then you have to do 5. Minus 5 minus 4.
Mm-hmm.
And that is minus 9.
Uh-huh. And so what's the gradient?
Gradient is 1.8.
So what? 9 over 5?
Yeah.
You can just leave it as, so it'll be minus 1.8, but basically minus 9 over 5.
Okay.
Minus 9 over 5 is fine. Or minus 1.8, whichever you want. Okay. Yes, so it's just second takeaway first. Any questions about that?
Yeah.
Find the gradient of this line. How do you do that?
Okay. So gradient. Can the gradient only be 2 or can it be more?
Gradient can be anything.
Okay. So the line L.
So how could
That
you
will
find
be 2, 5.
2. So yeah, that coordinate is 2, 5.
And then the other one is 1, 2.
So 1, 2, yeah.
Then is it -1, -4?
Yeah. And so, how simplify it? What gradients do you get? It's not -4 actually. It's -1.
-1, 0.
How did you get -4?
Because I was looking at the one at the bottom.
Oh, okay. You don't need any more. Yeah, okay. -1, -4. You don't need any more coordinates. How can you use the 2 we have to get the gradient?
Okay. So then you do 2. 2 -1. I think that's right. Yeah. And that would be 1. And then do 5 -2, which would be 3. So then the gradient would be 1/3.
Other way around.
3/1.
Yes, it's change in y over change in x. And what is 3 divided by 1?
3.
Yeah. So the gradient is 3. And it's always the change in the y's over the change in the x. Or you can just kind of pick a point that you have. For every 1 right, you have to go 1, 2, 3 up to get back onto the line. 1 right, 1, 2, 3. 1 right, 1, 2, 3. And so the gradient is 3 because for every 1 right, it's 3 up.
Okay.
Any questions there?
No.
Okay. Okay, how about this one?
The gradient. Work out the gradient of line A.
Mm-hmm.
Do I have to do B as well?
No?
No, like question B.
Yeah.
Okay.
We'll start with A.
A. That would be 2550.
Yeah, and what's the very first coordinate?
The very first coordinate.
The one down here?
That was 0, 0.
Yeah. Okay. So how can we get the gradient?
Then you do 25 take away 0.
Mm-hmm.
And then that would be 25 take away 0 would be 25. Then you do 50 take away 0, which is 50.
Mm-hmm.
Then you do 50 divided by 25,
Mm-hmm.
which would be 2.
So you go to 2. So the gradient is 2. And B.
Which train is traveling at the greatest speed? You must explain your answer. You must explain. Train A.
And why is that?
Because it's going in a straight line. One train B is traveling A.
B is also a straight line.
B isn't like, because A you just go straight to the other corner, but B it kind of like isn't as sharp as A.
So you could say because it takes longer to travel the same distance. So let's say it took, after 15 seconds, it had only gone 20 miles, but A had gone 30. Or you could also say it has A because it has a steeper gradient, like a bigger gradient.
Yeah.
Yeah. So, and if we were to go straight across, yes. So, A went 30 miles in 15 minutes. B only went 20. Or A reached 30 miles after 15 minutes, but it took B 22.5 minutes to travel 30 miles. So a few different things you can say. So train A because the slope is greater, or you could say something about speed, or something about the times. Any questions there?
No.
Okay, and gradient of 2. So that's just kind of a real thing. Let's see. How about this one?
A pine tree is growing in sandy soil. Work up an estimate for how much height this tree will increase in a year. Compare the rate of increase of the height. Okay, well that's how much stands. How much the height of this tree will increase in a year.
So we want sandy soil. So which is the sandy soil line?
The X one.
Yeah. And so any idea how you could work out how much the height of the tree increases in a year?
Follow the marks, the X marks.
So you'd just use the line. The line is like the average line.
Okay. So it goes. Oh my god, that's really fun with that tree.
So you could compare, let's say this is 25 years. And this one is, I think it's 19 years. And what would you have to do to figure out how much it grows each year?
Gosh, this is hard.
You would find the gradient. And so if you find the gradient tells you what the increase is for every one change in x. So for every one right, how many up does it go? And it looks like a half, but you would just get 2 coordinates and find the gradient. Yeah, so let's see. So it is, that's a gradient of 2. Okay. That is alright. Okay, how could you get the gradient for this one?
Look at the gradient on the straight line. So the straight line. There's okay, so there's links on it's 25. There's one on 25 and 4.
It's not exactly. Is there any exact one you can find?
Yeah.
Go on.
30 and 2.5.
30 and 2.5, yeah. And which is the x, which is the y?
30 is the y and 2.5 is x.
Yeah. And can you find another?
32 and 2.
2 and 32. Yeah. And so what you'd usually do is pick like the end and the beginning. So how about this one? What is this one?
That's 40, 0.
So that's 0, 40.
0, 40.
And a kind of easy one looks like here. That looks like 520. And so you would try to use those to get the gradient. So let's see. So that's going to be minus 20 over 5. So this gradient is minus 4. And what is part B? What does that mean?
Part B. Write down the practical interpretation of the value you worked out in this part. Do you have to just say how you did it?
It means, what does that mean in the context of this question? So in the context of this question, so it's usually for every one change in x, it's m changes in y. What that means in the context of this question is, because it says hours, so every hour the depth decreases by 4 centimeters.
Okay.
4 centimeters. So it's every hour because the x is in hours. So for every 1 hour, the depth, so the y was depth, and it decreases because it's minus 4. So it decreases by 4 centimeters. And so minus 4. So depth decreases by 4 centimeters each hour. Yep. Any questions there?
No.
Okay. So gradient of the line, that's okay. Gradient of the line and practical interpretation. I think gradient's okay. Gradient's okay. I would do. So the gradient here is 1.4. What would be a practical interpretation of that?
1.4. Look, the thing goes up by 20 every 10 minutes.
Yeah, or what I'd say is every minute the distance increases by 1.4 kilometers. Increases by 1.4 kilometers. So it was minutes for the x. So for every 1 minute, it's y. It's 1.4 kilometers. Okay. Let's see. Train A. What do you know about the speed for train B in this one?
Speed for train B. It's gonna be faster than train A.
No. Train A's speed is increasing. It's going up. What's happening to the speed of train B?
Slowing down.
That would be if the line was going like that.
Also speeding up as well.
That would be if it was also going up.
It's going up a normal speed.
It has a constant speed. So train B has a constant speed. And it's 23 miles per second, I think, or meters per second. Yeah, so if you see a flat line like that, that means it has a constant speed. Okay, let's see, gradient. Okay, so what do you give yourself for gradient?
Oh.
Yeah, this is very tricky because it's put in context. Okay, so this one, you have to, so it is y equals mx plus c. M is the gradient, c is the intercept. So y equals 3x plus 5. What is the gradient? What is the intercept?
The gradient and the intercept. Gosh, what is gradient? P.
No. Any idea about gradient?
Oh gosh.
So the gradient is the number in front of x. The intercept is the number without x.
The number without x. So the gradient is 5 and the intercept is 3x.
Other way around. The gradient is 3, the intercept is 5. And so if you have the equation of the line, you can know that the gradient will be the number in front of x. Do you know what the coordinate is of P?
No.
The x will always be 0 and the y is 5. Because anything times 0 is 0. So 3 times 0 plus 5. And so that is basically 0c. 0c. Okay, so this one. What is the gradient? What is the intercept?
The gradient and the intercept. The gradient is 3.
Minus 3.
minus 3, and the intercept is 5.
Yeah. And so if the intercept is 5, what are the coordinates of the y-intercept?
Coordinates. Oh, mine. Would it be yeah? Would it be minus 3 minus 5?
It is always 0 on the x and then c, so 0c. So if this equation of a line, if the intercept is 5, then it goes through 0, 5. And for a real graph, that's where it starts from. Okay, how about this one? Gradient intercept.
Gradient intercept. The gradient is 3. Intercept is minus 2.
And so what are the coordinates of the intercept?
Coordinates are minus 2, 3.
0, minus 2. So the x is 0 and the y is minus 2.
Okay, yeah.
So the x is always 0 for that one. Okay, so first one, what is the gradient?
The gradient. Jeez, there's a lot of functions. The gradient is 5.
And the intercept?
Intercept is 2.
How about question 2?
The gradient is 1/5.
Yeah.
And intercept is 4.
Question 3?
2. The gradient is 2 and intercept is 5.
Something's missing.
Minus 5.
Yes. So let's see. That's good. How about question 6?
The gradient is minus 3.
Mm-hmm.
And the intercept is 0.
Yes. And any idea of question 5? Looks different, same idea.
Question 5. That is, the gradient is minus 2. And the intercept is 4.
That's it. Well done. Great. Okay, how about this top one?
Write down the equation of a straight line that is parallel to y equals 5x plus 6.
Any idea how you do that?
No, I have no idea.
So parallel, it'll have to have the same gradient.
Okay.
So another equation of a line, same gradient, different intercept.
Same gradient, different intercept. Okay, yeah. So the gradient is 5 is 5. So 5 on the x-axis. And then 6. No, not 6. Minus 6.
Yep, it's just anything else. So y equals 5x minus 6. Yeah, y equals 5x and then any different number. And how about the bottom one?
The bottom, write down an equation of a straight line that's parallel to the straight line of y equals 3x minus 5. Okay, so it would be y equals 3x minus 6.
Yep, that's fine. Y equals 3x plus or minus any other number. That's it. Let's see. Yes. So how do you make it y equals for question 1?
Y equals
Or for question 1, what is the gradient? What is the intercept?
gradient is 5, intercept is 3.
Question 2.
Minus 2
Mm-hmm.
and 6.
C equals 6. And yeah, these are okay. It's good. Let's see this one. A and B are straight lines. Does A and B intersect? I'm gonna leave that one. This is different stuff. Okay, so oh, hang on. Yeah. Okay, how about this one?
L is a straight line. The gradient of L is 4. L passes through the point 0, 2. Write an equation of the straight line L. Write an equation of the straight line L.
So all straight lines can be written in the form y equals mx plus c, where m is the gradient, c is the y-intercept.
Okay.
And so what is the equation for this line?
The equation is y equals y equals x plus 2.
Plus 2 is correct. The gradient is 4.
Okay. So 4x plus 2.
That's it. That has a gradient of 4 and y-intercept of 2. Y equals 4x plus 2. Y equals 4x plus 2. This one, what is the equation for this line?
The equation diagrams is a straight line. On the row on the grid, a straight line is parallel to the straight line. Passes through the point. Find an equation of the straight line. Okay.
And so for every one right, it goes a half up. What does that tell you?
The gradient is going to be half.
Yeah, so the gradient is a half. And it says L2 goes through 0 minus 5.
And
so
then the intercept will be minus 5.
And so equation of the line.
It will be is it y equals half x minus 5?
Very good. That's it. Gradient is a half. Y-intercept is minus 5. Y equals a half x minus 5. This line here, what is the y-intercept for this line?
Which one?
Which one? L1.
The y-intercept would be
go through the y-axis?
4.
It's under 4.
No, 3.
Yes. And so what's the equation of this line?
Y equals half x minus 3.
Plus 3. Yes. And so that's how those work. And yeah. And so what do you give yourself for that one?
Tick.
That's good. And so this one, work out an equation. Yeah. Yeah, how was that for you, Carlos?
It was good.
So I tried this one because it's quite challenging. And so if you want, so we did half of it, 60 out of 120. So if you want, we can do the second half next time.
Okay, yeah.
Any questions for me in general?
No?
Alright, well done, Carlos. You did great. I look forward to talking to you again next week.
Yeah.
Have a good week. Goodbye.
Bye.